Let's begin. So we're looking at the first lesson, looking at functions and relations. So yeah, we'll see what a function is. This course is grade 11 functions. So we'll see what the title of the course relates to. So before we actually get started, hopefully you took a look at the Desmos activity that's available online. And if not, then feel free to stop this video now and go back to it. And yeah, with that activity, you're looking at the turtle, measuring its distance over time, and then some funny things happen depending on how you had made your graph. All right, so first of all, just a couple definitions that we need to get to. So we have a relation. So this is actually what you've been working with pretty much for most of the past couple years in math. It's basically a pattern between two variables, which you can represent as either ordered pairs, as in coordinates, points, a table of values, a graph, or an equation. And they can be simple equations, they can be more complex. And another way we might say this is we can have an x which may go to more than one y. That might not make sense just yet, but we'll be able to use that to compare it to a function. So to begin with, in the lesson, what I want you to do is I actually do want you to go through the first part of the lesson just on your own. So I'll do this example so that you can see what's expected, and then you'll see a number of different ones with different equations. So this first one, x plus 1, is not on your sheet, but how you go through this is I just want you to write down what the rule is in words. So the y value in this case is 1 more than the x value. And then what would the table of values be? Well, if x is negative 3, substitute it in. Negative 3 plus 1 is just equal to negative 2. And just continue to sub in values. You get negative 1, 0, 1, 2, 3, 4. So that's your relation as a table of values. And lastly, I want us to write the relation as a graph. So then we can just plot our x and y. These are the points. So the first one would be the point negative 3, negative 2, negative 2, negative 1, negative 1, 0, and so on. And so negative 3, negative 2, we can plot that down. It would be the point there, negative 2, negative 1. And you'll see it's just a line. So something that you should have dealt with lots. Oh, it's a line, but I should draw the line correctly. Negative 3, negative 2 is down. Negative 2, negative 1. And it's going upwards, positive slope. X has got a 1 in front of it. And so we end up with something like this. So there's our line. Let's draw it with a straight line. So use a ruler if you have it. And then add arrows at the end, because this could keep going on forever in both the left and right direction. All right, so that's the expectation. So go through the rest of the equations in this initial investigation part and fill in the table of values, fill in the rule, just try your best to find a way to put it into words, and then plot the graph. So some of these equations will be familiar, some of them will not be familiar. So do your best, and then pause the video for now, and then come back to this video when you're ready to see how each of those will look. All right, let's take a look at the rest of them now. So we have y equals x squared, which is the square of the x values will be your y value. And so if you do that, you will have 9, 4, 1. 0 squared is 0, 1, 4, 9. It's just a parabola that we're going to end up getting. So you should have looked at this before. And we'll just plot down those points. And you will get that parabola shape occurring. So there's the left side of the parabola, the right side of the parabola, and arrows at the ends of that graph. Okay. Next we have y equals 2 to the x. So your variable is now in the exponent. We sometimes call this exponential. And we'll actually have a unit dedicated to this kind of thing. So if it's new, that's fine. We will look at that. So the y values are powers of 2. So that means if you were to substitute in 2 to the negative 3 will be, we have to be careful because negative exponents actually make a fraction. So it'll be y to 1 over 2 to the thirds, or 2 to the 3, I should say. And then that'd be 1 over 8, which is 0.125. But if you can, leave your answers as fractions, but sometimes having a decimal, if you're plotting it, it can help just, figure out where that is on the graph more accurately. And so let's continue. 2 to the negative 2 is 1/4, which is just 0.25. 2 to the negative 1 is 1/2, which is 0.5. 2 to the 0, be careful of that. Anything to the power of 0 is actually equal to 1. And then 2 to the 1, 2 squared is 4, and 2 cubed is 8. All right, and let's plot these points. So the starting points will all be really close to that x-axis, and then we get higher and higher up as we go along. So you'll have something that's pretty flat to begin with, and then as you go to the right side of the graph, it increases quite quickly. Okay, and that's an exponential. So next we will look at sine. Yeah, so you would have been introduced to trigonometry, seen sine, cosine, and tan, and you would have looked at triangles, but, well, you can just plug numbers into sine and get answers. So let's see what happens here. So if you plug in 0 into sine, well, that will just actually give you 0. If you plug in 90, like 90 degrees, well, sine of 90 degrees is actually just 1. And if you keep going, just plugging it in, you'll get 0 again. Sine of 270 is actually negative 1, 0, back to 1, and back to 0. Okay. And we'll actually go through a whole unit just based on these kinds of graphs. But if you're just plug in numbers and plot down your points, you'd have something that looks like this. So you will graph it out, and you may have been tempted to draw straight lines. It actually doesn't end up being straight lines. So if you drew a straight line like that, it's actually a little more curved. But again, we'll see that later in the course. You aren't going to be asked as of yet to reproduce this. That'll come for later. Okay, so there you have it. That's what the graph would look like. So the y values there are the sine of the x values. And next we have a square root, so a root graph. And if you try to do the square root of, well, did not mean to do that. If you try to take the square root of negative 3, well, let's see what happens. If you type that into your calculator, you're going to get an error. Because, well, no two numbers, or no number multiplied by itself, can equal a negative number. Two negative numbers multiplied by themselves will be positive, so this is not possible. So actually, any of these negative answers are not possible. The first thing that we can actually get an answer to is, well, just 0. The square root of 0 is 0. The square root of 1, well, it's just 1. Square root of 2, what number multiplied by itself gives you 2? Well, if you type that into your calculator, you will get something like 1.41. You can do the same with the square root of 3, so they're not nice numbers always. And oftentimes we can just leave our answer as the square root answer. You don't actually have to round it off to a decimal. And the square root of 4 is a nice number too. Okay, and let's plot this to get this graph. So our graph is going to start here at 0. It's going to go up to 1, 1, and just slowly go up from there. 1.41, 1.73, and 2. And we'll draw a curve. And what you're going to see with this time for this graph, I'm only going to draw an arrow on the right-hand side. Because nothing's happening to the left, I'm not going to draw an arrow to the left because the graph is starting at 0, 0 and only goes towards the right. And the last one, 6 over x. So again, just plug in your numbers. This sometimes we would call a rational graph. Sometimes you might also see the term hyperbola. Both terms are acceptable. I typically use rational when we're going through our course here. So that is what we have there. So if you plug in the numbers, 6 divided by negative 6 is negative 1. 6 divided by negative 3 is negative 2. 6 divided by negative 2 is negative 3. And then negative 6. What you'll see though is when you get to 6 divided by 0, well, you can't divide by 0. So just like we had with the square root, you can't get an answer for that, so that's just going to disappear. And then we basically get the answers in reverse, but positive. So we get 6, 3, 2, 1. So let's just plot those points, and then we'll see what this graph actually looks like. So -6, -1, -3, -2, and so on. And then we basically jump over to the other side. You'll see it's kind of a mirror image, but just now in the positive section. Okay, so we have some points. How do we add points together? Well, it's basically two different pieces that we're going to have. So we're going to have this piece in the bottom left corner. I'm going to draw an arrow on the two ends of that. And what's going to happen is, yeah, it'll continue going towards both of the axes, whether it's the x-axis or y-axis down there, the x-axis to the left. The graph continues to move towards it, but will actually not ever reach it. Then, well, you can never actually have a point when x is equal to 0, and then it jumps over to this other portion. And again, we'll have a lot of times going through these kinds of graphs. This is just a first look at it. So we kind of have that symmetry across the axes there. All right, so that's just an initial look at some different kinds of relations. Okay, so what is a function? Well, a function is actually just a specific kind of relation. It's one where each value of the independent variable, so each x value, we can say, corresponds to exactly one value of the dependent variable. Feels a little odd. We can also say that each x goes to only one y. And as we spend more time with it, hopefully it'll make more sense. But at first, the definition might not seem like the most obvious thing. But let's take a look at these. So here we have some relations. In this case, we have it written as points. We have a set of 5 points. And if we take a look at the x values, we have x equal to 5, x equal to 6, x equal to 7, x equal to 8, x equal to 9. Each x value has only one corresponding y value to it. Or each point only contains, or all of the points together only have a point for each x value. So for each x, only one y value. So again, I know this might feel a little odd. It does take a little bit of getting used to. So therefore, a function. So that set of points, that relation is a function. It doesn't have to always be an equation, because there's different ways we can write relations. Okay, let's take a look at this next one though and how it compares. So we've x is 1, x is 3, x is 5, x is 6, and x is 5 again. Okay, let's take a look at that one again. So we have 5, and we have 5 here. So we actually have the x value 5 showing up twice here. And for the 1, we have a corresponding y value of 6 and a corresponding y value of 4. So what's happening here, and this is where the difference is going to come into play, is the x value of 5 has 2 corresponding y values. Four and 6. So therefore, not a function. So that's what we kind of have to look for, is where are these points where you have the same x coordinate but two different y coordinates. Another way we can write out relations is we can look at what we call a mapping. Basically, mapping is just, whether you call it a mapping diagram, is it just shows us what our x value is and the corresponding y value is. That would actually be like, here it's saying x is going from 0 to 0. That would be the same as just saying the point 0, 0. The input, the x value is 0. the output, the y value, is 0. And if you take a look at the next part, you could have the point 1, -1. 1 goes to -1, but also 1 goes to 1. Well, that is 2 y values for the same x. So it's not a function. And you can see the 1 here has 2 arrows coming from it. Makes it not a function. In comparison, though, if we take a look across here, 1 only goes to a single y value. 2 only goes to a single y value. And it's okay if they go to the same y value. So I'll write that down. It's okay if x's go to same y value. It just can't have 2 separate y values for a single x, or 2 arrows emerging from x. 3 goes to 5, 4 goes to 4, 5 goes to 4. Each of them only has 1 arrow, so it is a function. Let's continue. So if those, we're always looking at points, looking at individual x values, but one of the main ways we have relations given to us is through graphs. That's what you're doing in that investigation. And so how can we tell if a function is a function or not? If a relation is a function or not? Well, we can use this thing called the vertical line test. And what it tells us is if any vertical line intersects the graph of a relation more than once, well, then that relation must not be a function. And the question is, why does this work? Well, let's just do a rough sketch of a graph. And what I'll do is I'm just going to draw something that actually does have something that crosses twice. So let's just say I draw a graph like that, draw a graph like that. Say it's going there and there. Okay, there's kind of the separation, that's fine. But if I were to look at this vertical line that I just drew, that vertical line goes through twice. But what are those? Well, if you take a look at that, those are 2 points. And what's true about those 2 points? Well, that has an x value of something. And I'll just say this is, let's say, 2 for y value and 1 for the other y value. So it's x, 2, and below we have x and a height of 1, or y value of 1. Well, look at that. You have the same x value going to 2 different y values. And that's actually what the vertical line test is checking. Is that it's just checking that if you have the same x value, which is what a vertical line is, it's just a single x value. Well, if you cross more than once, you have more than one y value for that corresponding x value. So a vertical line checks if a particular x value has more than one y value. Okay, and so that's the vertical line test, so let's put it to work. So if we take a look at this first one, this circle, well, what you can do is basically start from the left side, start with the vertical line, and just work your way across. And if at any point that vertical line, as you're going across, ends up intersecting twice, well, then that will tell you whatever you have is not a function. So there I drew a vertical line, crossed twice, therefore it's not a function. It's just a relation. Whereas, let's take a look at this next one. If I draw a vertical line, and you want to make sure it works everywhere, that first vertical line only crosses once. This next vertical line only crosses once. You can pretend like you have a ruler, hold the ruler vertically, and just take that ruler across from left to right. And if that ruler only ever crosses a single time, each single time you are looking at it, or as I draw each of these vertical lines, well then we've got a function. So in this case, you can see all those vertical lines only cross once. So therefore, it's a function. Let's keep going. So in this case, we have to be a little bit careful. Because if we start drawing vertical lines, it'll cross once, and then we get to kind of the special point where the graph, it jumps down. So the question is, when it jumps down, what's actually happening there? Just trying to draw a nice straight line here. So what we need to go over is just what these circles mean. So the open circle means the point there not included. Whereas the filled in circle, the point is included. So what's actually happening in this graph is it gets really, 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 really close to this x value of 1 at the top. It does not reach the actual value of 1. So what we can say is it gets close to 1, but does not reach it. And that's because it's open, as we would say. So it's not filled in, it's open. And then, well, actually right below the graph is filled in. So as soon as you hit x equal to 1, you are now below. So you reach this value instead. And then, as you can see, the graph continues down to the right. So that's what's happening there. What does this mean for the vertical line test? So everywhere else, like you can see, if you draw a vertical line, it's going to be fine. It's just this particular jumping point. But because at the top it's not open, or it's not filled in, it's open, it means we're actually not reaching that value. So we're not actually, in a sense, crossing there. We only cross down below. So that's just once. So it never crosses twice. So therefore it is a function. Okay. And, this last one's an equation. How are we going to deal with this? So we don't have the vertical line test in this case, unless you can try to graph things out. But we need to keep in mind, what is the definition of a function? Well, we're looking at, for a single input of x, how many y values do you get? And so if you do that, well, let's see what happens. Let's sub in a value for x. Doesn't actually matter what value. So I'll just say can use any x value. Let's just do 6, why not? So if I were to sub in 6, you'd get 6 is equal to y squared minus 3. And I just want to see, well, what's the corresponding y value? Well, move the minus 3 over, you get 9 is equal to y squared. And if we were to solve for y, well, you might be like, okay, take the square root of 9. It's the opposite of squaring. And we can use opposite or inverse operations, as we might call it, to solve. And you might think, okay, 3 is our answer. Given our x value, we get our one answer. But we need to be careful, because with square roots, we could have a plus or a minus answer. Because not only is 3 times 3 equal to 9, but negative 3 times negative 3 is also equal to 9. So there's 2 y values for the one x value. So it is not a function, actually. So you could say it's just a relation. All right, and that's a look at that. So again, it's just a little bit of definition work for this first lesson, just to get us used to what the word function means. And yeah, you can go through the practice, make sure, check your understanding, see how well you understand what you just went through. And that's a wrap for this.